Hello and welcome to the video of LLMs, vector databases, embeddings, and AI frameworks. So today we'll be discussing about what are large language models, what are vector databases, embeddings, and AI frameworks. So these are all basic terms, but I just want to go over them to get a basic understanding of how things work before going into in depth. So after these videos of basic stuff, we will move on to some complex things. So, what is a large language model? A large language model is a deep learning model trained on massive text data sets to understand and generate human language. So, how, for example, ChatGPT was trained is they took large chunks of internet data and trained their models on that large amount of data to basically predict a sequence of tokens. So, an LLM is nothing but a predicting machine which predicts tokens. So it doesn't understand what does each token mean. It does only predict based on probability that if the probability of coming that human would come after generate if the probability of this specific word of this token is more than 90% or something like that, then it would print this word. So what the purpose of a large language model is to answer questions and summarize documents, translate to different languages. It can generate content such as stories, code, or poetry. Code is probably the most advanced or important use case of large language models, and then enable conversational AI and chatbots basically simulate our conversation just like we do with some human. What are the key characteristics of a large language model is that the scale that it is trained with billions of parameters. It is generative, so there is something called predictive and then generative. So by generating means it can produce new content which it has never seen. It is pre-trained. So pre-trained means it is pre-trained like you can say like GPT is generative pre-trained transformer. So P stands for pre-trained. Fine-tunable. So you can adapt it to do specific tasks for your need. For example, you can go into GPT and ask it to perform a specific task and feed it with instructions so it can use its baseline data and then use your instructions to work over them. Then we can move on to the concept of vector databases. So what are vector databases? Vector is just so they are scalars and they are vectors in maths. So to understand what a vector is, you can just Google what is a vector. It's just like what is a vector, and we can understand that a quantity which has both magnitude and direction. But in terms of machine learning, a vector is basically an array. So you can call it array. And then what the purpose of vector databases enables semantic search by comparing similarity between vector representation of data. So within two arrays or vectors, we can calculate similarity and different things because these come into matrices and vectors and arrays, so that becomes easier for machine to implement. Embedding is basically representing the data into tokens and words which can be tokens and numbers which can be fed into the vector database. Then indexing is used to organize algorithm. Example 5 is NSW for fast lookup. Uh, and then I think HSW is hierarchical navigable small words. So we'll go into that in the next video or something. Querying a queried vector data is matched against the store vector for more similar data points. So these all of these things come into under RAG. So if you can understand RAG, then you can understand these things. So a basic overview would be that there would be some embedding, some chunking, information extraction, and the query would be also be embedded, and then all of them would be matched in the vector database. The use case for this would be semantic search personality. personalized commands, images, and facial recognition anomaly. So anything that you can do with an LLM, but this time would be faster with a vector DB. Embeddings are also used in these things, so they have a numerical vector representation of real-world items like words, sentences, or images. So the purpose is to capture semantic relationship between data in a way that a machine can understand. So similar concept like closure in vector space, and the farther apart they are, the different they are. How they are created using during learning. Easy word to vec glove fast text to convert them to embeddings. Extracted text from pre-trained models. So they use text from pre-trained models like BERT or GPT. For example, king minus man plus woman is equal to king. Queen is equal to is the word analogy of the thing. Image embedding used in facial recognition or visual search. Then we can go into LangChain framework. So LangChain is an open source framework for building applications powered by LLM with a focus on modularity and reusability. Our purpose is to simplify LLM application development by connecting modules, tools, and memory into coherent workflows. So LangChain basically provides you a way to interact with LLM and do development after if you have got a model from anywhere. It can provide you integration with models. It can provide you prompt templates. It can provide you a sequence of operation. LLMs can make decision and use tool autonomously. It can give you memory between detection and most important thing is retrievers to fetch data from different sources. The benefit for this is model it is modular and composable design. It is easy to deploy and prototype and works well with external data and APIs. Next we can go into AI agents. So an AI agent is an autonomous system that uses LLMs and tools to perform tasks on behalf of users. So the key traits for this would be reasoning, planning, memory, tool use, and autonomy. So what an agent would be is how an agent would be in real life. You give it a task and it would perform that complete task, like booking your ticket on a plane or doing something like that. So how they work is observe, think, act, and learn. So they have a environment, that they have a state, and they learn from their environment, and the state changes upon the action. So example would be virtual assistant, research agent, developer, assistant, CG, co-pilot, or something. So for the framework part, we will discuss Agno framework, formerly known as PyData. So now it is an open source framework to build modular, maintainable, and Pythonic AI agents. So it provides you clean abstraction components to streamline agent development. What are the core principles of this framework is that is composability. So reusable, so less code. Pythonic design means it is similar to Python and tooling built-in support for APIs, memory system and reasoning aids structured for multi-step thinking. What are the benefits for using a framework? Cleaner and code base for complex agents. It would simplify debugging and testing, extensible and modular design, and ideal for production ready system. But let's say you want to go into more depth, so you can just type it into Google. You can read it from the documentation as well. So here you can go on the website Agno Framework, go in the documentation to get a bit of understanding about what is Agno Framework and how it is formed. And yeah, what is Agno is an incredibly fast multi-agent runtime routine and control plane. It is a framework which is agent OS runtime, agent OS control plane, etc. etc. And then you can get code examples as well. So yeah, this would be it for this video. Thank you.